Hi, everyone. Thank you for joining the Lunch and Learn. We're just waiting a couple more minutes to begin. All right. Maybe wait one more minute and then we'll get started. Is now good, Carolyn?
Yeah, I think we can get started. We'll probably get a few more folks, but nobody else is in the waiting room at this point.
Okay, perfect. Welcome to the Lunch and Learn. I am not Christine Osborne. I'm Jody Garberg. I work for the Division of Water Quality and manage the watershed protection section. I think I've met most of you. We have a great presentation today by Gigi Richards, right? Richard. Gigi is the director of the Four Corners Water Center, and she also teaches geosciences at Fort Lewis College. She's going to talk about snow and watershed monitoring in the Animas Basin and geomorphic monitoring of the Dolores River. So super excited to hear Gigi today and to see all of you here. She's going to share a presentation. I'll just remind people that this is being recorded so you can see it later on. And then also if you can use the chat function for questions or, you know, I don't know, Gigi, do you take questions during your presentation? Then?
Yeah,
okay.
That'd be great. Yeah.
Okay. Well, take it away, Gigi.
Okay.
Thank you.
Awesome. Thanks, Jody. And I just want to check in. Are you all seeing my PowerPoint?
Yes.
Okay, great.
Yeah.
Awesome. Thanks.
Uh-oh. Did we just lose Gigi?
Froze up.
Oh no, Gigi, you're frozen.
Minute, I'll send her a note in the chat as well.
Okay. I don't know if she knows. I definitely can't give this presentation in her stead. Maybe.
Just send her a note. I'll see if she can log in and out again. Oh.
Yeah, either that or call in maybe.
And I can also run the presentation for her too, if that's
okay, good. Good. So please stay on the line. Okay, we can see
back.
you. Okay, good.
The internet just went out.
I know, like bad timing, huh?
All right, we'll try this again. There we
okay.
Go. Okay, there we go. Are you seeing my screen?
Yes, we can see your screen and we can hear you.
Okay. Well, hopefully that'll be the last time that happens. All right. I'm not sure where I got cut off, but I'll be sharing about a geomorphic monitoring effort on the Dolores and then some small watershed snowmelt hydrology work in the Animas watershed that's part of a statewide effort collaboration with CSU in Fort Collins. So before I get started, I just want to do a land acknowledgement. At Fort Lewis College, we always start every event, even virtual ones with an acknowledgement of the land on which we gather. And Fort Lewis College is situated in the Animas River watershed, which is the ancestral land of a number of indigenous tribes, including the Ute, the Hickory Apache, the Pueblos of New Mexico, the Hopi, and the Dene nations. And we acknowledge the setting because the narratives of the land in this region have long been told from a dominant perspective, without full recognition of the stewards who continue to inhabit and connect with this land. And from the Water Center's perspective, we also always want to acknowledge that we are all 2/3 water, and water connects us all, and that we are part of a much larger watershed, and what we do here in the headwaters flows downstream to our downstream neighbors. So we try to keep that in mind as well. And I just wanted to point out, you know, I'll be talking about the Animas watershed and then the Dolores as well, which is outlined in gray here. Before I get into those two projects, I wanted to share a little bit about the Water Center at Fort Lewis. It was started in 2019 by President Tom Stridicus. And we are an interdisciplinary center dedicated to working towards solutions to our water challenges. And in order to do that, what we're working on is cultivating that next generation of water leaders. So trying to get our students engaged with local water issues and research and studies. Fort Lewis has a really amazing breadth of faculty who are working on water issues. And so we're working to create some water curriculum that take advantage of all of that amazing strength that we have across disciplines on campus. And then I'll also talk a little bit about what we're doing with this information hub, water data. It's in its very, very early stages, but I think can potentially be a great resource for the region. If you're interested in learning more about the Water Center, our website is fourcornerswater.org. And on that website, if you scroll to the bottom, you can find our social media feeds, and then also sign up for our newsletter. We only send 2 newsletters a month, and what we try to do is provide a compendium of events and webinars of relevance to Four Corners regional water. So basically the Dolores and San Juan River watersheds. And then we also share some Colorado statewide water news and events too. Also, there's a focus to some extent for student jobs, internships, that sort of thing. So one of the things that we do is host a happy hour monthly for water professionals. It's usually on the 3rd or 4th Wednesday of the month at 5 p.m. In Durango. So you can find out more about that on our website as well. So if anyone has questions about the Water Center, don't hesitate to reach out. So I'm going to start off talking about our watershed monitoring efforts. So this is a collaborative effort that's been ongoing since 2015 between Colorado State University in Fort Collins, Fort Lewis College, and Colorado Mesa in Grand Junction. So there have been numerous students and faculty at all of these institutions involved in this effort. And it's been a really neat opportunity to get undergraduates engaged in some hydrologic monitoring and research. So the idea for this project came from Dr. Stephanie Camp. She's really the lead for this project. She's in watershed science at CSU in Fort Collins, and she had a graduate student, John Hammond, who's now has his PhD and works for USGS in Maryland. But as part of his PhD work, he took MODIS satellite imagery and mapped throughout the entire West the persistence of snowpack, and classified each pixel as whether there was snow on in the pixel or snow off from January to June from the year 2000 through 2017. If a pixel has snow on for more than 75% of the time from January to June, that pixel is classified as being in the persistent snow zone. And so, so persistent is snow on more than 75% of the time from January to June. Transitional is 50% to 75% of the time there's snow, and intermittent is 25 to 50% of the time there's snow. And then low snow, which in this map is shown with no shading, are areas where there's less than 25% of the time from January to June there's snow. So, you know, one of the things that we know with our snow tail measurement, and of course, snow is extremely important for our water in Colorado. Our snowpack is really our water tower. And so understanding the amount of water in our snowpack is really important for understanding what's going to happen with our runoff and our stream flow. And in Colorado, our snow tail measuring sites, which are run by NRCS, are primarily up in that persistent snow zone. So we don't measure our transitional or intermittent snow zones as frequently spatially. So one of the efforts with this project is to try to better understand what's going on with our watershed hydrology in those 3 snow zones, from persistent through transitional down to intermittent, in different regions of the state. And to also, you know, that we understand too that our intermittent snow zone, we know, is much more vulnerable as climate changes, as climate warms. So understanding what's going on with that more vulnerable intermittent snow zone and even into the transitional snow zone can be really valuable for our water resource managers as we move into a warming climate. You know, another thing we might notice with our monitoring, and this map only shows 5 stream gauges because I pulled this from a different analysis that we did, but generally we tend to measure stream flow lower down in our watershed. So we're measuring snow really high and stream flow lower down. And so one of the other efforts here is to have a little bit better look at how stream flow is generated in these small watersheds. So there are 12 monitoring stations around the state. Well, actually, I should say there were 12 monitoring stations around the state. The ones that were supported by CMU have now been removed. But Stephanie still supports some in the Front Range above Fort Collins. And these are our 3 sites in the Animas River watershed. Our persistent snow zone site is Senator Beck Basin, which is technically actually just outside of the Animas River watershed. It's at the very top of Red Mountain Pass, and it does flow into the Uncompahgre, but it is right at the top. We chose that site because it is a long-term, a site that's been monitored long-term by the Center for Snow and Avalanche Studies. So there's a lot of valuable data there, and we actually share data with them and they share their data with us. So our transitional site is at Relay Creek, which is in the upper Hermosa watershed. It's above the area that burned in the 416 fire, and it's kind of behind Purgatory Ski Resort. And then our intermittent site is down at Basin Creek, which is a creek that flows into Lake Nighthorse. And we partner with the Bureau of Reclamation and the Animas La Plata Operations, Maintenance, and Replacement Organization for operating that site. So those are our 3 monitoring stations in the Animas River watershed. So what's involved in this network, and this is, some of this is just a little bit of fun sort of sharing what we've done with students. The installation at all of these sites can often be really challenging. It's been amazing how difficult it is to find small watersheds that are entirely in one of these snow persistent zones that are not regulated by any kind of diversion or dam or structure, that don't have a lot of roads or other disturbance in the watershed, and that we can access year round. So wintertime access can be challenging and problematic, but it's been a fun effort to get this set up. So at each of these stations, we have either a tipping bucket or weighing bucket rain gauge. We have wildlife cameras pointed at snow stakes to measure snow depth. Every time we visit, we'll take cores to get snow density so we can get our snow water equivalent. So measuring precipitation, and all of these methods are not without challenges. Tipping bucket rain gauges don't do well when it freezes. The wildlife cameras, I'll share some interesting pictures with you, but we've had a lot of problems with those too. So, oh, and I should mention too, I have a student right now who's working on using machine learning to process the images from these and detect the snow stakes and automate the measuring of snow depth from the stakes. So it's another sort of exciting sideline to this. We also measure stream flow at each of the sites. Some of the sites have pressure transducers and some have capacitance rods for measuring depth. And then we do discharge measurements whenever we go visit to develop a rating curve so we can estimate or measure discharge. At each site, we also measure soil moisture and temperature. So we have soil moisture sensors at 3 depths. And then we also measure air temp and at some sites relative humidity. We also sometimes monitor wildlife and have challenges with animals. One of the sites on the Grand Mesa, there was a grazing permit there and the cows would move through, and then we have some fun going through the images from the wildlife cameras each time we pick them up to see who else visited our sites. We also often have a lot of challenges with exactly the thing that we're measuring, and that is snow and water. Digging these sites out and the freezing that can happen and that sometimes breaks things it can be really challenging. I had some really ingenious MacGyvering students to try to get this PT out of the ice. They had brought a propane torch, but realized we didn't want to melt the plastic. And so they put water in the snow shovel and heated up the snow shovel to get the water hot, and then poured it in there, and we got the PT out. So that was I thought a clever solution. Sometimes we can't find the stream gauges because they're completely buried. That's been a challenge. That was especially a challenge in 2019 up at Senator Beck. So to give you an idea of some of the data that we get from these, and I know this is kind of busy, but I'll step through it. This is at Senator Beck, looking at the 2018 water year. This is the first year that we monitored up there. This top one up here, we have precipitation coming down from the top using this axis here. We have soil moisture at 5 centimeters with the solid line, 20 centimeters with the big dash line, and 50 centimeters with the dotted line. Accumulation of snow depth. I don't have SWE plotted on this one. And then stream flow is discharge in millimeters per day over the watershed. And then air temperature. And so we can see our accumulation of snow as air temperatures start to warm up and our days start to get longer. The response, the first thing that happens when the snow starts to melt is it soaks into the ground. We see our soil moisture responding, and then following that, we see stream flow respond. Oh, I mentioned one time we couldn't find our stream gauge here. We never did find it until the snow started to melt there. And when it did emerge, this was 2019, it was broken. And so, of course, the year that we most wanted to see the response, because this is one of our bigger water years in recent years, the instrumentation was completely broken and we didn't get any stream flow data. And because of the depth of the flow burying our depths of the snow, burying our solar panels, we also lost all of our soil moisture data that year. So really frustrating. Okay, so what are some of the things we've learned from this? Oh, and I should have pointed out that I'm not going to share a ton of really groundbreaking results because we're still have a lot of work to do on all these data. One of the other things that we've learned is that having data collected by 3 institutions at 12 sites produces a lot of data and takes a lot of processing, a lot of challenges for data management. So It's been a good learning. So just interesting, connection between snowmelt, groundwater, and surface water. Our persistent site on the Front Range at Michigan Creek, snow depth here in blue, and I'm just going to focus right here on this 2017 water year. Compared with the Grand Mesa, they had really similar snowpack, but check out the response in the stream. So really flashy, peaky hydrograph, whereas on the Grand Mesa, high base flow and much lower runoff, and then our peak runoff. So much more attenuated snowmelt hydrograph with much higher base flow, which makes a lot of sense given the underlying geology of the Grand Mesa and how important groundwater and springs are on the Grand Mesa. So something we really didn't expect. Another interesting thing, our original intermittent site on the Grand Mesa had the stream never flowed. And so it's helped us see and emphasize the importance of some other factors that we kind of weren't expecting through this process. So finally, just a few graphs showing our full record for our Animas station. So here is our Senator Beck. So this is our persistent snowpack station at the top of Red Mountain Pass. Similar to what we had before, here's our soil moisture. This is our big data gap in that 2019 water year where our data logger there died. And then I've got the Red Mountain Pass SNOTEL snow water equivalent. 2018, recent drought year, 2019, much higher water year, and then our kind of more average snow years of 2020 and 2021. And then the stream response measured in millimeters of discharge per day. So this is taking the rate of flow and spreading it out over the watershed. And then our air temperature down here. So we can see as temperatures start to warm up and the snow starts to melt, our soil moisture starts to go up first, and then the stream flow begins to increase once we start to charge up those soils, the moisture in the soils. And I don't have any of our 2022 water year data. Okay, so then moving on. So Senator Beck is our longest data record for the Animas watershed. We installed that one in fall of 2017. Moving down to our transitional site at Relay Creek. This is the one above Purgatory. Snow water equivalent at the Scotch Creek nearby SNOTEL site. Oh, I should point out too that this was one of the sites where we had a lot of problems with the camera for our snow depth. The good news is that for the time periods where we do have our snow depth data, the data match really closely with the Scotch Creek SNOTEL site. So, so we feel good about using the nearby SNOTEL site for this watershed. Let's see. So much lower snow water equivalent than at the persistent site, which is what we would expect. You can see really clear response of soil moisture to precipitation events. So each of these blue lines coming down is a precipitation event, and we can see our soil moisture respond. And moving down all the way down to the 50 centimeter depth for some of these bigger precipitation events, and the delayed stream flow response. So we see soil moisture coming up and then the stream flow with a little bit more delayed response. And then our intermittent site has been really tricky. At our intermittent site, the stream, not surprisingly, it's ephemeral, it's flashier, and we've had a really hard time getting a decent rating curve for that site. So I don't actually have any of the flow depth to share with you. I've worked closely with Susan Bahari with the Bureau of Reclamation, and she's actually done a lot more work on taking our flow depth data and trying to get some sort of useful stream flow data out of that. And not surprisingly, with the intermittent snowpack, we see a lot more spikes and peaks in soil moisture, a lot warmer soils too, and then a little bit more responsiveness in the soil moisture from the monsoonal peaks in the summer. So that's kind of an overview of where we're at with our monitoring. And I did want to point out that this project is a big collaboration amongst a lot of different entities, and without the support of the Bureau of Reclamation and ALP, O&M, the Center for Snow and Avalanche Studies, we've, permits and working with the Forest Service, and then Purgatory Resort and Snowmobile Adventures have helped us get back to our intermittent site. It would be quite a long ski in. And then we also have had funding from USDA, ARS, Southwest Climate Hub, the Colorado Water Center, CWCB, and USGS. So it's been a very well-supported, collaborative, cooperative effort. Okay, now I'm going to shift gears and talk about this Dolores River Geomorphic monitoring effort so that I can share a little bit about the database that we're working on associated with this project. So this project, our acronym is DRAMS, for the Dolores River Adaptive Management Support Project. And once again, this is a big collaborative effort. And the academic team includes geology and biology faculty at Fort Lewis, and Joel Schultes, who's an engineering professor at CMU in Grand Junction. And in addition, many other partners, including River's Edge West, Bureau of Reclamation, Forest Service, BLM, Conservation Legacy, San Juan Citizens, Dolores River Boating Advocates. And then this project was initiated by questions that were raised by the Native Fish Monitoring and Recommendations team, which is a very large group of stakeholders in the Dolores River Basin, and a subset of them have been involved in our project. Our primary funding's from CWCB, but there's a lot of support from Dolores Water Conservancy District, Nature Conservancy, Southwestern Water Conservation District, and Dolores River Restoration Partnership. So it's a 5-year monitoring effort. We started last year. We spent about 6 months or so developing a monitoring protocol, and the underlying motivation is focused on habitat for native fish. I'll talk a little bit more about that. And then it also includes development of public sharing data platform. And as part of this project, we have developed a website, which I will share with you. If you go to doloresriver.org, it takes you to the site, and on the site we have a story map that tells the story of the DRAMS project. So this is a great place to go look at some of the work that we've been doing. And also you can access our monitoring protocol report here as well. So you can head over to doloresriver.org if you want to check that out. The goals of the monitoring effort are focused on how the channel and the floodplain and riparian area are responding to the new water and sediment regime following the closure of McPhee Dam, and to attempt to assess the trajectory of channel change. We're very interested in what's going on with riparian vegetation, because that's been an important driver in what's happening with simplification of the channel. And the idea is that these data could help inform flow management and release recommendations, and also potentially inform future physical projects for restoration. The focus on channel characteristics is on those that are critical to native fish habitat. The native fish of interest are the 3 species of interest: the round-tailed chub, flannel-mouthed sucker, and the bluehead sucker. And so looking at assessing clean spawning gravels, connection to side channels, channel complexity, and pools. So that's kind of what we're looking at. Our monitoring effort is divided into 2 main pieces. One is a set of monitoring that will happen every year. And then another effort is a responsive effort. And the idea is we want to be able to mobilize responsively when hydrologic conditions warrant a high flow release, or if we're, and potentially also some of the monsoonal flows. So we've seen some impact from that. So just, I know this is a lot of text on this slide, but I just want to kind of share, like, there's a lot happening associated with this monitoring. So a piece of it is historic analysis using remote sensing and then historic data. A piece of it was baseline monitoring that was accomplished last fall, including UAV flights, drone flights of our study sites, and I'll show you where those are in a sec. Some other topographic surveying, substrate analyses of the bed material, long profiles of side channels, oblique repeat photo points, some discharge measurements for use in future model calibration, and then vegetation monitoring. And then annually in the summer for veg data and the fall for geomorph data, there will be some field surveys of cross sections, including pools, focused GPS surveys of side channel inlets and outlets, substrate analyses, the repeat oblique photography, and then vegetative transects. And then if we do have high flows, we will get out and deploy water level sensors, do some substrate movement detection efforts. During the high flow, if possible, they want to fly, do some drone flights. And then after high flow, definitely do a drone flight to see if there's any channel change, and then redo some of the topographic surveys. So it's a pretty big effort. We have tried to streamline our monitoring so that we utilize remote sensing when possible to minimize field data collection, given the travel distances to the sites that can be make it hard to get out there. And we're also trying to focus on data that will support the monitoring. So the river has been broken into study segments, study reaches, and field study sites. We have 5 field study sites from upstream to downstream, Dove Creek Pump, Slick Rock, above and below Disappointment Creek, one in Big Gypsum, and one at below the confluence with the San Miguel. The study segments are is where they're doing a lot of the remote sensing work that I'll share with you some results. The study reaches are where we're doing the drone flights, and the field study sites are where we're actually doing on the ground cross-section surveys. To give you a sense of just what these look like, Dove Creek Pumps is up by the Box Elder campground. It's a more confined canyon reach. Disappointment Creek brings in more sediment than water. So we see a change in the character of the river from above and below Disappointment Creek. It's also key for fish, changes in what's available for fish. And also Colorado Parks and Wildlife has a fish pit tag array at Slick Rock upstream. All of these 3 sites have been monitored in the past over time. And let me jump ahead to now our Slick Rock downstream, so below Disappointment Creek. The Big Gypsum site has been monitored probably since the 1990s, so we have a lot of data there. And then Salt Creek is a new site where BLM has been doing some channel clearing. So just to share some of the preliminary results, I think this is where things get really interesting. Dr. Alan Kasbrak and Dr. John Harvey at Fort Lewis College have worked with a few of our GIS students to analyze some of the channel change, and they've taken advantage of a really cool resource. There's an organization called Planet Labs that their satellites are taking pictures of the Earth every day at 3-meter resolution. So what they were able to do is go back to the 2019 high flow release and capture days where there are no clouds. So you might have daily pictures, but there might be clouds every day, so it's not useful. So you have to find cloud-free days and find the discharge on those days, and then digitize all of the channels. So the Planet Labs imagery, and I just realized I didn't include an image in that. I'm going to pop over actually to the website, because in the story map, this is actually really cool to see. I'll open up a bigger version of it. And if we go to the geomorphology piece, sorry, just be scrolling. Here we go. This is what I want to show you. So the Planet Labs imagery look like this. They're infrared, so the vegetation shows up as red, water shows up as this darker color. So it's really easy to detect where there are channels that have been inundated. And so what they've done is digitized all of the channels, including all of the side channels, at different discharge levels during the 2019 release. And then they've also done that for 1982, which was pre-McPhee Dam. And so this is one of the resources they've created, is this ability to swipe back and forth and scroll along the channel so that we can more readily, you can really clearly see the encroachment of the vegetation, simplification of the channel, and narrowing of the channel. So these results then are showing the blue line is 2019 total side channel length at different discharges. The red dot is total side channel length in 1982. So at all of the sites, except Ponderosa is a canyon reach segment and Bedrock Canyon is a canyon segment, at all of the other segments of the river where the river has more ability to move around and is where we've seen more changes, we see a reduction in side channel length. And one of the pieces of this that can be really useful for decision-making about releases is to look at, so for example, this Slick Rock site below Disappointment Creek, from 1600 CFS to 2000 CFS, we see a really big change in the length of inundated side channels. So in the future, you know, thinking about planning releases, if we're trying to get more water into side channels, maybe getting to 2000 CFS should be a sweet spot, a target, whereas maybe getting up then beyond that to 3000 doesn't really give you as much bang for your CFS buck. So, so that's the kind of thing we're hoping to be able to understand more about the channel from this effort. Just to share some of the results with you, or some other the data. This is from Joel Schultes for the Salt Creek Reach. This is downstream of the confluence with the San Miguel. The DEM, or digital elevation model, that results from their drone flight. These are using structure from motion, which is kind of, you think of the old USGS elevation that you got from using stereo imagery. So it's the same thing, does not remove vegetation. So that has to be dealt with and filtered out. One of the things they're working on is comparing the elevation model from the structure from motion with survey grade GPS RTK and seeing what sort of accuracy they're getting. So it's about 1/10 of a meter at this point with the drone flights. The drone flight of the Big Gypsum Valley, this is one that's been resurveyed many times with also a lot of fish work there. We also have groundwater monitoring wells on this point bar. So this cross section here is going across that point bar. And then these are two of the profiles, which is some of the, we have it, this is all just done in November. So they're working on processing it now. This past summer, there was a very minimal release from McPhee Dam, but we did have a monsoon season, and Disappointment Creek, the one I mentioned that has more sediment than water, flowed into the Dolores. So this is wading across the Dolores River during those monsoonal flows. The deposition of that sediment had a pretty dramatic impact on the channel. John Harvey was out at the Slick Rock sites following those monsoonal flows in November, and you can see the deposition of sediment that occurred. At that site, they resurveyed a pool that was surveyed pre and post flood in 2017. And just to give you an idea of what happened there. So here's this orange is March of 2017, the bottom of the pool. The high flow of 2017 scoured that pool out. So scoured about 3 feet of sediment out of that pool. And now in 2021, that pool then has refilled with another about 5 feet of sediment at the deepest portion. So one of the things we're learning from this process is these really low flows with the monsoonal flows may have as much of a geomorphic impact as we would anticipate our high flows to have. So not surprising, but as we move into a drier period, we're firmly embedded in a solid drought period right now. So these low flows may become more controlling on what's happening in the channel. Oh, and here's some of the 3D results from that the structure from motion drone flights for this Sequoia Reach. Oh, right. So then all of this data, so there's been a lot of work done on the Dolores. So there was some interest in pulling all of this data in from all the different entities who've been collecting it and putting it into a single public repository that would be accessible to everyone. And so we, as part of this grant, we were able to pay Lodic Hydrological, a consultant out of Carbondale, to build a Metacat database for us. And we're using Metacat because it's flexible, it's open source, and it allows you to document your data, your metadata, your documentation, your data about data are all documented in a standardized way. So the data are well described, consistently described. They can easily be searched, compared, merged, used in different ways. And this is the same platform that is used by numerous other databases such as Data One, and there are many others. HydroShare is now using it, and there are others, and it's used throughout the world. So I'm just going to pop over back here. So if you go to waterdata.fortlewis.edu, that will take you to and this is very much in its infancy, and you'll see like we still have practice data sets, test photos. So we're just, finally, we were able to get this going on the Fort Lewis server, which was a huge undertaking for both Fort Lewis IT and Seth and Bill with Lodic Hydrological. So, but all of the data have geospatial referencing, so we can zoom in, and as you click on a site, it tells you, let's see which one. Let's go to this one. This is our Big GIP site. So there are 3 studies here at the launch. And then if you click on one of the studies, you get the data. So in this case, it's a spreadsheet. Oh, so one of the other cool things about a Metacat database, it does allow you to store data of any type. So just PDF studies, PowerPoints, Excel spreadsheets, GIS data. And it also allows, if you have scripts that run on data that you have used to process your data, you can show the provenance of the raw data through the processing to the final output. The data can be downloaded here. There's an abstract. You have keywords to make it searchable, tied to your study sites, key people who collected the data, who to contact to if you want to find out who to contact to get a hold of about the data. We have a lot of work to do to kind of tidy up our metadata to make it all consistent across all of the different sources that we have. But I just wanted to show you what this at a full build out looks like. So this is the Data One database that ultimately ours will look more like. And so it's searchable, and so you can see this really similar format where you can download the data, but then also things are just a little more cleaned up. So we're on our way there. And hopefully in the next couple of months, we'll at least have all of the 2017 studies through present loaded in the database. So, okay, so I did it. We had plenty of time for Q&A if anyone has questions. Awesome, thanks.
That was fantastic, Gigi. I am so impressed with the number of partners you have, the different types of data that you collect, and then the way it's stored and accessible. So just fantastic work, really. And the mission of the Four Corners Water Center, just so impressive. Thank you. Thank you.
Thanks.
Yeah, did anybody have any questions for Gigi? We have a quiet group today.
At school, we're at that point of the semester where everyone's just
Right.
you know?
Point in the year where so Eve Rich said incredible. Will the PowerPoint be made available to the group?
It can be, sure.
Oh, good. Thank you.
Or I think you're recording it too, aren't you?
Yes, we are. Send it to Carolyn Gillette or to Christine and I, and we'll post it. Yeah. Well, I'm going to go look up Metacat database because that was a great way to store your data. And we're exploring. Do you use high frequency data in that database? Do you take high frequency data? Yeah, I didn't think I saw that. Well, that's what we're exploring right now.
Mm-hmm. Yeah, I get the impression Metacat is really powerful.
Oh, good.
And it does take a little programming on the back end.
Mm-hmm.
You know, in the future, we'll hopefully have them build some data entry forms for us that will make it a little more streamlined for the data entry. But I mean, I've already been playing around in it, and it's pretty straightforward. So,
ooh,
yeah,
excited about that. Someone asked a question: are there any plans to increase snow level monitoring in the transition area?
that's a great question. So not with our project, but there is another effort. It has a little bit different focus happening in the Dolores Basin. It's well, actually, it's in the Chicken Creek watershed. With the Dolores Watershed Resilient Forest the Dolores Watershed Resilient Forest Collaborative, and they're calling this, they call it snowtography, and they're similar thing. They're using the wildlife cameras, but they're trying to understand accumulation of snow in areas of the forest that have been treated for fire mitigation versus areas that are not. And I just saw an email there, they actually got some more funding to expand that. And it's much more in-depth snow monitoring, and like 6 cameras per site with 26 stakes per site. So they have transects of snow depth that measure in the treated area and in the untreated area. And so, for example, the student I have working on the machine learning to process the imagery, those are going to be really valuable. That will be really valuable with all of the images that they have to process. So that's all that I know of for additional snow monitoring that's happening right now. Yeah, they don't have it paired with stream gauges though. So they're much more, they do have soil, they're measuring soil moisture and snow, but it's more associated with forest treatment.
All right, last call for questions.
Okay.
Well, if we don't have any more, thank you so much, Gigi, for sharing your data with us. That was super interesting. I'll allow Christine to send out the PowerPoint and tell you about the next Lunch and Learn. So thank you everyone for joining us today. Really appreciate it, and really appreciate the presentation today.
All right. Thanks, Jody.
Okay, bye everyone.